Okay, question 5, determine the equation for the sinusoidal function below. So now we're looking at a graph. We have to write the equation. And when it says a sinusoidal function, you have two options. You can use sine or cosine. And it just depends what's going on your graph. And the best way to tell is to look at your intercept on the y-axis. So if I'm looking here, see how the intercept is kind of halfway through the curve? It's not at the maximum. So on sine, that's where our intercept is. It's halfway through the curve. But on cosine, it's at the maximum. So for this one, I want to use sine. So my general form of sine is y equals a sine of bx minus c plus d. And we're going to go through each step. So very first thing, I want you to find the midline of the graph. So think of, on this one, it's y equals -2. Because you get the same distance, oops, that should be 2, above the midline. So that's 1, 2. As you do below, that's 1, 2. So my answer for that's the midline, and that's D. So y equals -2, D equals -2. And that means the graph has shifted down too. So this point that we saw started here, we're moving it down 2. See, now it's at 0, -2. That's what D is. Okay, and that jumps right into our next one. We want to find the amplitude, and we already found it. It's the distance from the midline to the top and to the bottom, and it's always going to be the same. So our amplitude, or our A, is 2. So that's 2, and that's 1/4. And it's +2 because our slope didn't change. So see how that just stretched it? If it were -2, I would change that slope, that starting slope, to a negative. But we are going positive. So it's +2 because the slope is positive. Okay. Third thing we want to find is our B value. And we get that from the period, because the period is 2 pi over B. Absolute value of B, if we're speaking technically. So the period is when we repeat. I like to go from maximum to maximum because that shows me it's going to start repeating again, maximum to maximum. It's cyclical, just repeats. It's a wave. So what we do is we take the larger value minus the smaller value, and you're like, but there's pi's and that's scary. It's not that bad. The denominator stays the same, and then we take 5 pi minus 1 pi, which is 4 pi over 4. Guess what happens to the 4's? They go away, and we're left with pi. So pi is the period. That's what we just found. We're going to use that to solve for B. So maybe you can tell what it is already. So I'm going to times both sides by B. I get B times pi equals 2 pi. Divide both sides by pi. So B is 2, right? And if you would have just 2 over 2, there's pi. So B is 2. And then the fourth thing you look at is the C value. And you get that from the horizontal shift. So how has the graph shifted horizontally? And this one actually hasn't. that point that we started with on our regular sine graph, it's just come down. It hasn't gone left to right. It's still right on the axis, right at this -2. So this one actually doesn't have a phase shift. I'm going to type in what we got for B, and then you can always kind of check your answer. So look, there's pi force 0 right there. My next 0 is a 5 pi force 0. So you can graph these, and because we're in radians, it's showing the radian measures. Okay, so let's type that in. Y equals 2 sine of 2x plus, why did I write 1/4 there? -2, D is -2. That's weird. I can't remember why I did that. Okay, -2. Lots of 2's.